So on these, I'm expecting a parent function. How many points do you have to put on your parent function? 3. I feel like I say that every time, but still some people aren't doing it. So make sure, what's my parent function? X squared. 0 squared is 0. 1 squared is 1. Negative 1, 1. You have graph paper. It's not hard if you want to do some more. 2, 4, negative 2, 4. So we have this graph. Okay. The directions on here first said to describe the transformation. What will that 2 do? It's outside, so it's vertical. Does what it says, so stretch. What's the minus 5 do? Okay. If it helps you, you can write out points. You do not have to do this. Outside changes X or Y. Y. Outside is Y, does what it says. So if I take my Y times 2, 0 times 2 is still 0. 1 times 2 is 2. Negative 1, 2. And then we have to go right 5. So 0, 0 doesn't go anywhere. Right 5. Okay, 1, 1 goes to 1, 2. Right 5. Negative 1, 1 goes to negative 1, 2. Right 5. And that's our final graph. If I asked you to look at that and tell me domain and range, could you? Yeah. Domain is just your x values. What x values does it hit? Negative infinity, positive infinity. Hits them all. Range, what y values do we hit? 0 to positive infinity. Okay. Number 2. What is my parent function? Absolute value 0, 0, 1, 1, 2, 2. Negative 1, 1, negative 2, 2. Describing the transformations. 3 is on the inside. Inside is horizontal, and it does the opposite. So it will shrink. What's the plus 4 do? It's on the outside. Up 4. If you need points, do those. Well, the 3 is on the inside, so it changes the x's, and it does the opposite of what we think, so it would divide those x's by 3. So 0 divided by 3 is still 0. 1 divided by 3 is 1/3. And negative 1/3. 1. Okay, so 0, 0, the 3 didn't change it, and then we have to go up 4. Okay, 1, 1 moves to 1/3 1. Up 4. And negative 1/3 1 up 4. So we get this very skinny absolute value graph that's been shifted up. And that's why it's a horizontal shrink. It's like I took it in from the sides and squeezed it in. So it got skinnier. Questions on that one? What's the next one? What's the cube root function look like? A chair, but kind of flipped on its side. 0, 0, 1, 1, negative 1, negative 1. If you wanted, you could do 8, 2. Negative 8, negative 2. negative out in front do? Flip or reflect over the x-axis. Out in front, it's changing the sign to my y, so it flips it over the x, and the +3 would go 0, 0. If I flip, it doesn't go anywhere. Left 3. 1, 1. If I flip, it goes to 1, negative 1. Left 3. If you did 2, 8, and you flip, it goes to 2, negative 8. Left 3. Okay, negative 1, negative 1. If you flip, it goes up to positive 1. Left 3. And negative 8, negative 2. If you flip, goes up to positive 2 and left. Are these going okay? Why don't you guys try number 4? Parent function and transformation. Make sure if you're struggling with the points, think about like a t-chart. Y is equal to the square root of x for the parent function. Can you put in negatives for that? No. Square root of 0 is square root of 1. Can you do 2? Does it work out nicely? 3, 4, 0, 0, 1, 1, 4, 2. If you wanted another one, you could do 9, 3. So that's your parent function. So a negative underneath is making my x's negative, so it flips it over the y-axis. -5 is on the outside, so it will go down 5. So 0, 0. If I flip, it doesn't go anywhere. Down 5. 1, 1. If I flip it over the y, it comes to 1, negative 1. Down 5. 2, 4. If you flip, goes to 2, negative 4. Down 5. If you did 9, 3 and you flip, it goes to negative 9, 3. Down 5. So it should look like that. All right. Did we get it? All right, let's do a couple more together and then I'll have you guys try a couple. So the stretching and shrinking is probably the hardest part. If you struggle with that, write out those ordered pairs like we've been doing here. So if I look at number 5, what's my parent function? The chair, x cubed. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Negative 1, negative 1. Negative 2, negative 8. The 1/2, it's outside, so is it horizontal or vertical? And it does what we think, so it will shrink. What will the -4 do? If you need to on these ordered pairs, if it's outside, it's changing our y's, does what it says. So I'm going to take those times 1/2. So 0, 0 would stay. 1, 1/2. Negative 1, negative 1/2. And then we have to move it to the right 4. So we have 0, 0, right 4. 1, 1/2, right 4. Negative 1, negative 1/2, right 4. If you wanted more points, think about 2, 8. If you took your y times 1/2, it becomes 2, 4. And then right 4. If you did negative 2, negative 8. Y times 1/2 is negative 2, negative 4. And then we go right 4. So we get this fatter looking graph. notice that a vertical shrink and a horizontal stretch kind of have the same effect on the graph. They make it get fatter. Vertical stretch and horizontal shrink have the same effect. They make it get skinnier. Right. Is that one okay? Number 6. What's my parent function? Right. 0 squared is 0, 1 squared is 1, 2, 4, negative 1, 1, negative 2, 4. Right. What will the 1/3 do? Is it horizontal or vertical? Horizontal because it's inside. Inside does the opposite. So 1/3, to me that thing's smaller, but we know it's inside, so it does the opposite, so it's stretching. And the +2 on the end will move it up 2. Okay. Minimum of 3 points. Horizontal inside changes x, does the opposite. So times 1/3, what's the opposite of multiplying by 1/3? Yep, dividing by 1/3 or multiplying by 3 has the same effect. So we get 0, 0, 3, 1, negative 3, 1, 6, 4, and negative 6, 4 if you did those extra points. Then we take each of those, we move them to the new points, and then we go up 2. So I have 0, 0, didn't go anywhere, and then up 2. 3, 1, up 2. Negative 3, 1, up 2. 6, 4, up 2. And negative 6, 4, up 2. I want you guys to try the last 2 on this page. So on 7, our parent function is the absolute value, so the v. What will the negative do? Flip or reflect over x-axis. -1 and +3. Okay, so if I take 0, 0 and flip it, it doesn't go anywhere. Right 1, up 3. If I take 1, 1 and flip it, it goes 1, negative 1, right 1, up 3. If I take negative 1, 1 and flip it, it goes negative 1, negative 1, right 1, up 3. You can do more points if you want. We should get a graph that looks like this. Did you guys all get that one? Okay, number 8. I saw several of you had square root graphs. So remember, the square root is just this little piece. The cube root is like the sideways chair. What's the +2 do? And the -4? Okay, so if I take my point, 0, 0, left 2, down 4. 1, 1, left 2, down 4. If you did 8, 2, left 2, down 4. Negative 1, negative 1, left 2, down 4. Negative 8, negative 2, left 2, down. How are we doing with these transformations? So the back side, we're still practicing these transformations, but I've kind of switched it up a little bit. Let's see. These are not. Okay. So I gave you guys a picture of the graph. I don't know why I don't have the graph on mine. That's unfortunate. Let me change strategies here. Okay, so if I look at number 9, I did not give you the actual equation. Instead, I just gave you the graph. So if I'm going to do a transformation with this, I have to be able to pick some points on my graph. So let's just kind of identify some of these nice points here. So the ones that we can easily tell when we look at it. And then we have to ask ourselves, what will that -2 do to our graph? So what does a negative out in front do? Negatives flip it. If it's out in front, which axis does it flip it over? The x-axis, because it's like making your y's negative. And what would that 2 do? Stretch. It's like taking your y's times -2. So you might be able to do that from your graph. You might have to write out points. It just kind of depends on the person. If I want to just straight do it from my graph, I look, this first point, my y value is 4. 4 times -2 is -8. Okay, this point, -4 is 0. So y is 0. 0 times -2 is still. Here we have a y value of 3. Sorry, I don't know why it keeps trying to focus. 3 times -2 is -6. The next point, my y is -2. -2 times -2. Last point, my y value is 0. 0 times -2 is still 0. Now, if that confused you, you could have wrote out the ordered pairs to the side and multiplied your y's. Once I get to this point, then I'm just drawing in the graph, connecting the dots. All right. Number 10. So if I'm trying to take some nice points on my graph, what will my transformation be this time? Right. So the 3 on the inside would move it right. The +2 is up 2. So let's take each point. If I'm right here, right 3 up 2. -5, -2. So right 3 up 2. -3, 2. Right 3 up 2. So there's my little parabola looking piece. Take my next point. Right 3 and up 2. And then my last one. So we don't have to have the actual equations. I could just give you a random graph and we can translate it. Still same transformation rules. Okay, I want you guys to try number 11 and see if you can get that final graph for me. The first one, you have a negative on the x, so that flips it over. And the -4 will take it down 4. If you need to, you can write out points. Your x's are going to change. So we have, for instance, this is -10, -3. When you flip it, it's going to go to +10, -3. Okay, this is -7, 0, so it would go to +7, 0. That's what the flipping does. But then we also have to take them down 4. So I go here, down 4. So 7, 0, down 4. This is -4, -3, so go to +4, -3, down 4. This one is at 10, -3, so go to -10, -3, down 4. So it looks like that. All right. Last one. What will that +1 do? And the -4 is down 4. Okay, so take each point left and down. And then just copy the shape of your graph. All right. Any questions there? Let's go to the last few. We had some like this yesterday, I believe. So I'm giving you that we have a point on the graph. And we need to find the new point. So there's two ways of thinking about it. You could certainly draw a graph. My point is -2, 3. Okay, if I say x minus 2, what's that doing to my x's? Or what's that doing to my graph? It would go right 2. If you move this point right 2, where does it go? 0, 3. The other way we talked about, what I've said every time is outside is y, does what it says. Inside is x, does the opposite. This is inside, so it would do the opposite. So it would take my x and add 2. -2 plus 2 is 0. So negative f of x. That's saying what? Flips over the x. So my point will come down here. Or you could think, okay, outside is y. So if I make my y negative, -2, -3. Number 15. I am multiplying by 5. Outside is y, does what it says, so it's y times 5. So my x doesn't change. My y value times 5 becomes 15. Number 16. What am I going to do? Inside is x. We do the opposite, so x divided by 3. So that would be -2/3. 17, outside, so that is y, does what it says, so y times 1/4, give me -2 3/4. 18, what am I going to do? We're moving up 6. You can think about the graph, you could think outside is y, does what it says, so if you take your y value and add 6, you get -2, 9. 19, inside is x and does the opposite. What's the opposite of multiplying by 3/4? Okay, so if I take my x, -2 times 4/3, we get -8/3. Y didn't change. And last one, what is that doing? Reflecting my graph over the y. Or we can think about changing the sign on the x, so we get +2, +3. Are there any questions? So we've got about 20 minutes, and I have a similar but shorter version of this for your homework.